Saxon Algebra 1, Lesson 114, brought to you from my backyard. This is another super important lesson because it's a foundation for some work we're going to do next year to expand on this idea. And again, it's another super important topic that shows up in math classes and also science classes. It's also pivotal to understanding the COVID epidemic. So just know that these are the kinds of math concepts that are fundamental to what's going on right now to try to understand how this disease is behaving. The topic is called exponential growth. And whenever you hear this expression, what I want you to imagine in your mind's eye is a curve that looks like this. Okay, that's an exponential growth curve. And it happens when you have some, it's hard for me to talk and spell properly at the same time. When you have some sort of effect that is being multiplied, it involves multiplication. We're not adding, we're multiplying. The classic one is rabbit populations. They grow really fast. This is the way COVID behaved too, right? Where we had just a few cases early on and then it was spreading, it was multiplying. But then as you get more people, the multiplying causes this really big shoot up in growth. So this is what I want you to picture whenever we talk about exponential growth, something that starts out small and then shoots up. It's not a line, it's a curve, okay? And we're going to do a couple problems that give you examples of what kinds of things behave this way. But before we learn how to do those problems, I have to teach you how to learn a certain key on your calculator. What I would love for you to do is make sure that you have a scientific calculator that you can use. It can either be on your phone. You can do the calculations online. That's fine with me. Or you can get an actual calculator, which is kind of old school at this point. It does not have to be a graphing calculator. I'm going to say more about that later. Graphing calculators have the screen, but it has to have a button that looks like this. I have one on my phone. It's an app. I don't think it's the calculator that came on my phone. I have an iPhone. I think it's an app. I'm sure you can find one if you don't have one already, but the key is you need a button that looks like this, because what we're going to do is learn how to evaluate things that look super hard like this. It looks hard, but don't worry, it's not. This is the idea that we're going to take the number 1.06 and we're going to multiply it by itself 8 times. I don't want to multiply that by hand, and I don't have a button readily available that raises something to the 8th power. I have one that looks like this, for example, but we don't want to just square it, and I've got one that looks like this too. These lessons are kind of challenging for me to teach because my phone is filming, so I can't really look at it as we talk. I have to look ahead of time. But that's okay. So, these are not going to work because I don't want to raise it to the 2nd power or the 3rd power. I want to raise it to the 8th power. So we have this cool button here that lets us decide what the base will be and what the exponent will be. So that's the one I'm going to use. Yay. So here's what I do. First, I enter the base. You know how to enter numbers. There's not just one button, but you put in that button. Then you tap this guy. Then you tap 8, okay? So first you enter the base, then you hit this function key, then you enter the exponent. Okay, so you can also think of it that this is the X and this is the Y. That helps me remember which one to put in first because you do it alphabetically, right? X is the base and Y is the exponent. So you put in these three, and then you have to tap equals. And if you do that with this number, you will get 1.59 and a whole bunch of decimals. I'm not going to copy them all out, okay? So before we go on, take a minute, pause me, play around, make sure you know how to do this. If you don't, message me right away. Have your mom text me. I don't get notifications on my phone for my emails, but I do for like the messenger group I'm in with your moms. So I don't know what that says about me, but sometimes your emails, I have to go in and check them. And so that's why sometimes I don't get back to you as fast as I get back to them. It's nothing personal. It's just email. Okay, so this ability to calculate we're going to use as we actually do some problems that involve exponential growth. Yay, here we go. Enough preamble. Hopefully this lesson will not be as long as that last one on inverse and direct variation. That one went on forever, did it not? Oh, I thought I'd fallen asleep and it was Christmas. Okay, example 114.2, right? Because learning how to use the key was number one. All right, again, these are two-step problems, just like we had in the other one. The number of bacteria in the dish tripled every month. If there were 2,500 bacteria at first, how many were there in 10 months? Oh, I forgot to give you the cool formula that we use for these problems. Sorry, this is kind of important. You would want to know this. Okay. Y, okay, this is the amount at a certain time where t equals the time. This is the original amount. And some people think of this as either an O, meaning original, or you can think of it as a 0 for time. The time is 0 at this point, right? If this is 5 years, this would be the original amount. We'd put a 0 there. Y equals what we call the growth multiplier. I will tell you right now that this is kind of a simplified concept because John doesn't want to give you too much all at once. So in these problems, he's created sort of a simplifying factor. He just calls this number the growth multiplier. And again, t equals the amount of time. Next year, we're going to take this idea and we're going to expand it and make it more accurate. It has a constant in it. It's a little bit more confusing. So for now, we're using a simplified version of this part of the equation. Okay, so now let's go back to our bacteria. They tripled every month. So Y equals 3. That's our growth multiplier. There were 2,500 at first. So that means the original amount was 2,500. How many bacteria were there in 10 months? Okay, I forgot. I made these too hard. They're not a two-step problem. So we know that the amount after 10 years, which is what we're interested in, is going to be equal to 2,500. That's the original amount, times 3 to the 10th power. And I'm going to put parentheses around this to show that the 10 just goes to the 3. Okay? So what we can do is use our calculators to simplify this much. And then multiply it by 2,500. So what you'll do is you'll enter 3 x to the y 10 equals, and then times 2,500. I always draw these down. I'm not sure why that is, but that's the order you want to go. And the answer you should get, I wish I could show you, but I can't. It's going to have a lot of decimals. It's 4762 times 10 to the 8th. That is a hard thing for your calculator to show you. See if you can get close. Again, if you're having a lot of problems with these, let me know, and we'll sort it out. Okay. Not horrible, right? Some weird words, this funky looking equation with some weird, or formula rather, with some weird ideas in it. But it's not the worst thing in the world. Is it? No. The worst thing in the world, you guys, is the man-eating dragon with a bunch of radicals and complex numbers. I think that's the, ouch. I think that's the, maybe it's not the worst thing in the world, but the worst thing in the world is the Holocaust, North Korean concentration camps, which I've been reading about, so I'm super obsessed with right now. I've been reading about North Korea. And first-person accounts of people who have escaped from North Korea. It's spine-tingling in all the worst ways, not the good ways. Okay, so I'm going to write this again. The amount after any certain time is the original amount times this growth multiplier raised to the exponent of how much time has passed. That's our formula. You can look on the previous page if you forget what everything is standing for. Now, this works for science. It also works for business, specifically for interest calculations. If you put money in the bank and it's earning interest and you leave it there, you can use this formula to calculate how much money you'll have after a certain number of years. So, James, our friend James, I have a nephew named James, he deposited $500 at 7% interest, compounded annually. That's a really good rate. Good luck finding that now. How much money did he have after 14 years? Okay, so we can see, oh, this is his original amount. This is his growth multiplier, and this is the amount of time that has passed. So we plug it in. The amount after, is it 14 years? Yes. The amount after 14 years is going to be equal to the original amount, 500, times the growth multiplier. Okay, he's earning 7% interest, but he gets to keep what he already has put in the bank. So here's what's weird. This is his principal plus his annual interest rate. If we just multiplied it by the interest rate part, we'd find out how much interest he earned. But if we want to find out the total he'll have in the bank at the end of 14 years, assuming he doesn't take any out, we have to include the original deposit plus all the interest. Okay, so that's why that looks a little weird. And then we're raising this to the number of years. He leaves it there. That's the T. It's 14 years. Okay? So in these, we have to kind of build our growth multiplier. This represents the original deposit. Let me write that. Principal just is a fancy business word that means original amount. There. Okay, so this is what we have to do. So again, we have to enter all of this into our calculator. A lot of times with calculator calculations, we start at the right side and work backwards. That's often the way calculators are built to handle our processes. So we're going to do that. We're going to enter 1.07, then we're going to hit x to the y, then we're going to hit 14, then equals, and then times 500. I like to draw the buttons with rounded corners, but you know, this is a lot of buttons. So these are all the buttons that you're keying in. And in the end, you should get 1,289.27. We want to round it to 2 cent, to the closest cent, because this is money that we're talking about. If you put $500 in the bank at 7%, that would be the trick. No banks pay that much now. That's how much you would have if you left the $500 and then all the interest that you earned over the years. If you left it for 14 years, you would have 1,200 blah, blah, blah dollars. Okay, yay, right? If you wanted to find, this is the amount that you'll have. If you want to find the amount of interest, you would subtract the 500 principal, or the original amount, and you would get 789.27. That would be the amount of interest that you earned in 14 years. Okay, so that's another way John might pose these questions to you. Okay? Kind of fun. I hope you feel smart. All right. Now, next part. You're going to be happy because we're not going to do it. The next part, part C, talks about using a graphing calculator. When you get to pre-calc at the college level, that's when you'll start to use graphing calculators. I don't use graphing calculators. I don't use any graphing calculators in my program, because as soon as a student gets a graphing calculator in their hand, they stop thinking about math and they just think about pushing buttons. I don't want to talk to you about pushing buttons. I want to talk to you about the underlying math, what's going on. So instead of pushing buttons and finding out how to create these curves, I want to work with you on the math of this first, without the buttons distracting you. Then, once you have that good understanding and you get to college level math at EDCC if you're in Running Start or whatever. But my pre-cal, I don't use graphing calculators. Pre-cal is what John calls advanced algebra. It comes after Algebra 2. And we do a lot of exponential work, but we don't use graphing calculator. So I'm not going to do part C, and you don't have to do any problems that tell you, like practice B in your homework here. It says, sketch graphs of the following functions, then use a graphing calculator to graph the functions and confirm the sketches. Don't do it. We're not going to do that. Don't you love it when your math teacher tells you which problems not to do? Okay, so you can do practice A and you can do practice C, but you don't have to do practice B. Yay, we're done. Bye.